Right, grade 12. In this lesson, we're going to be continuing with three-dimensional trigonometry, but we're going to be exploring it in terms of compound and double angles. Now, in this diagram, you've got a shaded triangle which lies on the ground. Okay, the angle on the ground, that angle B there, is theta. These two sides, BD and CD, are equal in length. Okay, then you've got a vertical pole which is running perpendicular. It's coming down and it's perpendicular to the ground. Okay, it's perpendicular to this plane, this horizontal plane. And the angle of elevation, that's called an angle of elevation going up, is alpha. And remember, if you redraw this little triangle quickly here, this vertical triangle, this one here, okay, it's got a right angle at B. The A is the top. This is the pole AB. That's the angle alpha if you're going up that way. There, look at that. And this is going to be C. So it's a vertical plane triangle, okay, and it's right angled. Cool. Okay, now the other thing is the triangle on the ground looks like this. It's got the theta there, and these two sides are equal. Now, before we even start doing anything, what I want to do is I want to give you I want you to analyze what's going on in the triangles. Well, let's have a look. If we use a different color now, as a matter of interest, what would this angle be there? Okay, just a matter of interest, what would this one be here? Okay, well, if that's 90 and that's alpha, well, that angle A would be 180 degrees, subtract the 90, subtract the alpha, because these angles add up to 180. So if you subtract these two from 180, you'll get the piece there, and you'll notice that that comes to 90 minus alpha. So that angle there is 90 minus alpha, this one over there, 90 minus alpha. Okay, now what else do we know? If you think about it carefully, let's have a look. These two sides are equal in the bottom triangle, so this here must be theta as well, because that's an isosceles triangle. These are the same. So what would angle D be? Okay, that angle there, well, if you think about it, angle D is equal to the 180 degrees for the whole triangle, subtract the two thetas there. Okay, subtract those two thetas. So angle D would be 180 degrees minus 2 theta. So in here we've got 180 degrees minus 2 theta, and that one is 90 minus alpha. Okay, now here's some questions. Let's just think about this. The first question is calculate the size of angle D, or express angle D in terms of theta. Well, we've already done that, and that would be 180 minus 2 theta, because these are equal, these sides, so those two are angles. It's an isosceles triangle. So all we do is say 180 minus the theta, and you'll notice that all of these add up to 180. The two thetas, subtract the two thetas, cancel, and you're left with 180 degrees. Okay, now here's another question. Let's have a look at this, number B. Okay, number B says, prove. Okay, now how do we do this? Prove that the length of AB, okay, is 2d, now it's a little bit more abstract, 2d cos theta tan alpha. Okay, so AB is 2d cos theta tan alpha. Now how on earth are we going to do this? Okay, AB is 2d cos theta tan alpha. How do we approach that? Okay, well, let's have a look where, if we look at this, the information in the triangles, we've got to bring in the d's, the thetas, and the alpha. So we've got to connect these two triangles. But what I would suggest is let's start with AB. Where is AB at the moment, if we have a look at that? Well, AB is in this vertical triangle. Now, if you think about it, let's just redraw that triangle over here quickly. We've got a triangle here, and that triangle is A. B is the right angle, and that's alpha there, and that's C. Okay, now what we want to do, now this is important here, if you look at this in relation to alpha, that is the length of AB, what we want is opposite. And now I'm going to connect the adjacent side, because look, CB is going to help me get into this triangle here. Do you see? Okay, so I'm going to start off with the top triangle, the vertical, and then get and link it. The BC will link me to the other triangle there. Okay, now what can we do? Well, if you look at opposite over adjacent, the tan of alpha is the opposite over the adjacent there. Okay, is opposite over adjacent. Okay, so in other words, if you multiply both sides by BC, you're going to have BC tan alpha is AB, or AB is equal to BC tan alpha. So that's looking good. We've now got the tan alpha sorted. But now the problem is this. How do we get this into here? Alright, now, this has got D and theta in. We've already got our alpha from the top triangle. So the secret now, or the trick of this whole thing, is we've got to try and find something for BC and try and maybe connect it to this, if this could be BC. Well, we definitely have to use the bottom triangle. So let's have a look at that. If we redraw the triangle quickly, if we have a look at that, so I'm just going to draw the triangle on the ground quickly. What is that? That's B. That's theta there. This is going to be C and D. And we already worked this out as 180 minus 2 theta. And we've got this side as D, and that is D. Okay, so what we could do is we could use the sine rule, because we've got a lot of angles and sides. Okay, so what I could say is, well, the length of BC, if you think of BC all over the sine of the opposite angle. So what's opposite it? Is that 180 minus 2 theta. Okay, now you can pick any of the other sides, which would be little d, over, if you take that one, over the sine of the opposite angle, which is sine theta. Look at that. Okay, now come on. What do we know now? Well, this is a reduction. Sine 180 minus is positive sine 2 theta. That's the second quadrant. So if you use your rules from grade 11, sine of 180 minus is positive sine 2 theta. You can reduce it. Equals d over sine of theta. Okay, now all you've now got to do is multiply both sides by sine 2 theta. So BC would then be, now watch this, d multiplied by sine of 2 theta. It sort of comes up there, goes to the top there, divided by the sine of theta. Okay, now what do we go? How do we connect this to that? 2d cos theta, that's weird. If you have a look at this, do you notice what is lying over here? Is a sine 2 theta. And what is that going to be? That's 2 sine theta cos theta. Okay, that's a double angle. So what can we do here? We can say BC is equal to D multiplied by the 2 sine theta cos theta. That brings in beautifully your cos theta there, divided by sine. Now look at that. These cancel, and you're left with BC being equal to 2 times D cos theta. Is that not amazing? Look at that. There's an expression for BC. So if you go up and have a look here, there it is. We've got an expression for BC over there, which is great. BC is 2D cos theta. So if we read it down, so then we can say, okay, well, we know that AB is going to be, it's going to be BC multiplied by the tan of alpha. But what do we know about BC? Well, there's BC. BC is this. So all we do is we say AB is, what is BC going to be? 2d cos theta multiplied by the tan alpha, which is there. And guess what? There you've got it. You've now proved that AB is 2d cos theta tan alpha. Okay, now in the next question, what I want to do is number C here. Okay, I'm going to give you D as root 2. I'm going to give you alpha as 45 degrees, and I'm going to give you theta as 75 degrees. So I'm giving you some values here for these funny things, d theta alpha. And the question is, I want you to calculate then the length of AB. Do not use a calculator. Calculate the length of AB. But what do you know? You know that AB is equal to 2d cos theta tan of alpha. You know that from the previous thing. So all we've got to do now is we plug in the d, which is root 2. We've got the cos of theta, which is 75, and the tan of 45, which is alpha. Okay, the nice part of tan 45 is it comes to 1 in the calculator. So that reduces this to of 2 root 2 cos 75. Now we're not allowed to use a calculator. That just vanishes. That's 1. Now what are we going to do here with cos 75? Well, that's a compound angle. So all we do is we say AB is 2 root 2. Now what could this be? That's cos of 45 plus 30. Two special angles. 45 plus 30. What a pleasure. And this is exactly like we did in the lesson on compound and double angles. So what can we do with this 2 root 2? Now, what we can do is we can expand that. Remember, that's a cos A plus B. Now, if you look at the formula sheets, cos A plus B is the cos of A, which is that guy, cos A, cos of B, which is 30. Then we go minus the sine of A and the sine of B. Look at that. Okay, what a pleasure. Then, of course, we then say 2 root 2, and all you've got to do is work out special angles. Cos of 45 is root 2 over 2. The cos of 30 is root 3 over 2. The sine of 45 is root 2 over 2. You can almost use your calculator to do this. And sine of 30 is a half. Special angles there. I would just use my little, you can do it, no one will know, okay, if you use your calculator. Or you can use those triangles. Remember how it worked in the previous lessons, okay. So what does this give us? 2 root 2. Well, this is going to give us root 6 over 4 minus root 2 over 4. There we go. And then we can say that AB is equal to 2 root 2 into, that's root 6 minus root 2 all over 4. And the length of AB will then come to, let's have a look here. What would that be? Well, if we think about it carefully, the 2 can cancel into the 4 twice. Okay, so we've got root 2 into root 6 minus root 2 over 2. Okay, so what would the length of AB then be? Well, if we times that in there, root 2 times root 6 is root 12 minus root 2 times root 2 is 2 all over 2. Okay, and if you want to, you can actually make it a little bit you can simplify it a bit further if you want. You could say, well, if I like, instead of doing root 12, we can keep it as, watch this, you could say, well, root 12 was root 2 root 6 minus root 2 all over 2, over the 2 there, which then could be, if you think about it, it could be AB is equal to, you can haul out the square root 2 and you're left with root 6 minus 1 all over 2. That's one way of doing it. By the way, another way you could do it as well, if you look at this, you could say, well, if AB is equal to the root of 12. Now remember, the square root of 12 is also, so this is another way, you could say it could be 4 times 3 minus 2 all over 2. Okay, now that would then be, if you think about it, this is an alternative. The square root of 4 is 2. You still got root 3, so you could do that. And then you could maybe take out the 2. So there's many different ways that you could do that as well. Okay, which gives me just root 3 minus 1. So that would be an acceptable answer. This would be an acceptable answer here. And the other one at top here would also be fairly acceptable. Alright, so any of those would be fine.